All right, my darlings. So we are going to start by talking about how we use those mole ratios that we talked about yesterday to do calculations within an equation. All right, so for example, looking at this first problem, how many moles of water are produced if 15.0 moles of oxygen are produced in the reaction? So in other words, I know how much oxygen I have, so how much water is there? All right, so I'm going to use my mole ratios for my equation. So it's just like we were doing before. I'm going to underline moles of water. That's what they're asking me to find. I'm going to circle 15.0 moles of oxygen and label that the given. Then we're going to go through our list. Go through the rules. Given goes top left with units, so I'm going to put my 15.0 moles of O2 here. Rule number 2, top left has to match bottom right in unit. Moles of O2 here. Okay, where am I trying to go? I'm trying to go to moles of water. Moles of H2O. Now, this is where you have to ask yourself, can I do a mole to mole? The answer to that is, yes, I can if I have the balanced equation. Okay, if you've got the balanced equation, you can go moles to moles. All right. Now, they're asking for moles of water, so I'm done with my grid. I'm going to circle this because it's moles over moles. Remember, rule number 5 is moles always gets a 1 except if it's the mole ratio. Mole ratio is where you have moles over moles. So I'm going to circle moles over moles, and I'm going to label that mole ratio. You will do this on your paper, or I will take points off. This is part of showing your work, is showing me that you know how to identify the mole ratio. So what numbers do I use for my mole ratio? I use the coefficients that are next to that compound in the balanced equation. So if I look at the balanced equation next to H2O, I have a coefficient of 4. So in my equation next to H2O, I'm going to put a 4. Next to O2, I have no coefficient. So remember that when I have no coefficient, we assume that that is a 1. So I'm going to put that 1 from O2 in the equation in for O2 down here. So when I calculate this out, remember we multiply across the top, multiply across the bottom, divide the top by the bottom. Really what I'm doing here is I'm taking 15 times 4. So that's going to give me 60.0 moles of H2O. Don't forget your sig figs. Round to sig figs, and remember, number, unit, compound, number, unit, compound. Guys, this is where that becomes really important, because notice that we went from O2 to H2O in this equation. In all of these calculations, if you don't have number, unit, compound, it is going to be so easy to get lost in what you're doing. Okay, so number, unit, compound, and just make sure that you can see the progression from where you're starting to where you're going. So let's look at example problem number 2. Go. All right. Oops, nope, I can't see the equation anymore. Hang on. There we go. All right, this one says, how many moles of nitrogen gas are produced in the reaction if we start with 6 moles of ammonium nitrate? So I'm going to circle 6 moles of ammonium nitrate and label that the given. The cool thing about this, guys, is the mole ratios is I can go from any one thing in the equation to any other thing in the equation, because the equation is like a recipe. I can say that there's 2 ammonium nitrates for every 2 nitrogens. There's also 2 ammonium nitrates for every 4 waters. There's 2 ammonium nitrates for every 1 oxygen. So I can do multiple calculations using this one balanced equation. So we're going to go through our rules. Remember, rule number 1, given goes top left with units. So I've got 6 moles of ammonium nitrate, that's the NH4NO3. Rule number 2, top left has to match bottom right in the unit. So I'm going to take that moles of NH4NO3 and put it down here. Now I'm trying to get to moles of N2. Can I do moles over moles? Yes, as long as I have a balanced equation, which I do. All right, so now I'm going to circle moles over moles and label that my mole ratio. And again, you will do this on your paper, or I will take points off, because this is showing me that you know how to identify the mole ratio in your problem. Every time you have moles over moles, circle it and label it the mole ratio. So again, I'm going to use the coefficients for my balanced equation to fill in my numbers. So I need N2. The coefficient that I have for N2 is a 2. So I'm going to put that same 2 into my equation next to moles of N2. Next to NH4NO3, ammonium nitrate, I have a 2. That's my coefficient there, so I'm going to put a 2 in here. So I'm going to take 6 times 2, which is 12, divided by 2, which is 6. So this is going to be 6 moles of N2. That's my final answer. Not too bad, right? Mole ratio, pretty simple. Okay, so let's go ahead and flip that paper over and try something with an extra step to it, because we don't have any tools in our classroom that measure things in moles. The only thing we have is things that measure in grams. So we're going to need to, sorry, I cut myself off. We're going to need to know how to start with grams, or how to go to grams. So let's look at example problem 1 on the back. It says, how many moles of zinc, so let's underline that, that's what they're asking us to find, we want moles of zinc, are required to produce 20 grams of zinc chloride. So we're going to circle that and label it our given. Okay? So we want to know how many moles of zinc we need to start with in order to get 20 grams of zinc chloride. All right, so we're going to set up our grid. Rule number 1, given goes top left with units, so 20 grams of ZnCl2. Okay. Rule number 2, top left has to match bottom right in the unit, so I'm going to pull my grams of ZnCl2 down. Now, remember rule number 4, ladies and gentlemen, the only place to go from grams is to moles. Okay? And that's moles of the same compound. So I'm going to have to go to moles of ZnCl2. That's the only thing I can do from grams, is to go to moles. That's not what I want. I want moles of just the zinc. So now I've gotten rid of grams, now I need moles. So again, top left matches bottom right in units, so I'm going to put moles of zinc chloride down here. Where I'm trying to go is this moles of zinc. So I'm going to put moles of zinc here. Now, can I do moles over moles? Yes, I can, but I have to circle it and label it the mole ratio. And you will do this on your paper, or I will take points off, because you have to prove to me that you know how to identify the mole ratio. All right, so back to our rules. Rule number 5, moles always get to 1 unless it's the mole ratio. So over here, where we have moles over grams, that's not the mole ratio because it's not in our circle. So there, moles is going to get a 1. In our mole ratio, however, we're going to use our coefficients from our balanced equation up top. So next to zinc in my balanced equation, there's no coefficient. So remember, that means we're going to assume that it's a 1 and put a 1 there. Then we need zinc chloride, ZnCl2, and again, no coefficient, so we're going to assume a 1. So all that I need now is this right here. And remember, rule number 6 is that grams always gets molar mass. So we need the molar mass of zinc chloride. So grab a calculator. Okay, so for zinc chloride, we have 1 zinc, which is 65.39 grams, plus 2 times the chlorine, which is 35.453. So that's going to get us a molar mass for zinc chloride of 136.296. All right, so now all that's left to do is to multiply across the top, multiply across the bottom, and divide the top by the bottom. So I'm going to take 20 times 1 times 1, which gets me, no surprise, 20. Then I'm going to divide that by my 136.296. And that's going to get me a final answer of 0.1 moles of zinc. Sorry, it's over here. Ran out of space. Okay, so it's the same idea, but one step further, because we have to start with grams. We don't have any device that will measure moles. So we have to have a way to get from grams to moles of one thing, and then to get to moles of another thing. So let's try example problem number 2. Example problem number 2 says how many moles of hydrogen gas, so let's underline that, that's what they're asking us to find, are produced if 38.3 grams of hydrochloric acid are used. So let's circle him and label him the given. And let's set up our grid. Rule number 1, the given always goes top left with units. So I'm going to take that 38.3 grams of hydrochloric acid, which we know is HCl. Rule number 2 for the grid is that top left and bottom right have to match in units. So I'm going to pull grams of HCl down here. Rule number 4, the only place to go from grams is to moles. So I'm going to have to go to moles of HCl next. That's the only place I can go from here. That isn't what I want, so I'm going to keep going. All right, so top left matches bottom right, so I'm going to pull that moles of HCl down here. I want to get to moles of H2. Can I do moles over moles? Yes, as long as I have the balanced equation, which I do. Okay, but I'm going to circle it, moles over moles, and label it my mole ratio, which you will do on your paper, or else you will lose points, because it's important that you can show me that you know how to identify the mole ratio. Have I made my point? I hope I've made my point. All right, so what numbers do I use for my mole ratio? I use the numbers that are the coefficients from the balanced equation. So next to H2, I have no coefficient, so remember we assume that that's a 1. Next to HCl, I have a 2 for a coefficient, so I'm going to put that 2 into my equation. Rule number 5 says moles always gets a 1 unless it's the mole ratio, so everywhere else that I have moles, which is over here, I'm going to put a 1. And then grams always gets molar mass. So I need the molar mass of HCl. So we have hydrogen, which is 1.008, plus chlorine, which is 35.453. So my molar mass of HCl is going to be 36.461. So then to get our answer, we're just going to multiply across the top, multiply across the bottom, divide the top by the bottom. So I have 383 times 1 times 1, which of course, oh, I'm sorry, nope, 38.3. Oh, Miss Crane, you can't see that decimal. Boop, boop, boop. There you go, 38.3, sorry about that, times 1 times 1. And then we're going to divide that by, open parentheses, 36.461 times 2, close the parentheses. If you don't put the parentheses on the bottom, it's going to screw up your order of operations. So if you're going to do this in one step on your calculator, make sure to use parentheses for the bottom. So that's going to get me 0.525, and that's moles of H2. Final answer. So, similar to the calculations we've been doing, all we're doing is incorporating that mole ratio, which allows us to go from one compound in the equation to a different compound in the equation. So, if you want to start looking over the practice problems that are on this worksheet and see how much of those you can do, that's a great idea. But we will be having time to work on those 6 problems in class tomorrow. So come ready to work on those problems tomorrow. Thanks for watching, guys.